Okay, welcome to the second video in the series on reviewing for the common exam. Super critical review for the common exam. All right, so we're going to pick up electron configuration at a more sophisticated level, and we're going to talk about determining the valence of the elements that are in the nonmetal section here, that are down around in period 4. So the first thing I want to do is for practice and warm up is we'll determine the electron configuration as zinc, which is the last of the transition metals before we move to the right into the non-metal section. One of the main aspects of this particular video is to determine valence of period 4 elements. I'm just going to abbreviate that to the right of zinc. It's super critical, super critical. All right, so let's look at zinc. It's going to be, it's got 30 electrons. It's going to be 1s2, 2s2, 2p6, 3s2, 3p6. All right, and for those of you that have refused to learn this, we're out to about 18 electrons right here. And then we're going to have 4s2 and then 3d10. So this is 18 and 2 is 20, and then 10 is 30. Now, in the previous video, we talked about the simplified notation using a noble gas, and so we'll just do that quickly here. We're going to put argon in here, which is 18 electrons. Then we're going to have the 4s2, and then we're going to have the 3d10. So this is equivalent to Zincamundo. Yeah, there we go. All right. Now, you can see that with zinc, as soon as we move to gallium, that now we've added a 4p. So, in fact, why don't we just go ahead and do it? So if we do gallium and there's a total of 31 electrons, its configuration is going to look like. Let's use the simplified notation. So it's going to be argon for 18, and then we're going to have, whoops, I need my R in here. And then we're going to have 4s2, 3d10, and then we're going to have 4p1. All right, now, you guys, when you've looked at configurations like this before, I'd say 50% of the class cannot answer the following question, either on a test or on a whiteboard. And that question is, what is the valence of this element? All right, so the thing that you need to realize is that once we move to the right of zinc, the 3D shell is full. It is a full shell. It's not included in the valence. Not in the valence. Not in there, okay? I'm going to say it one more time. The 3D, once we move to the right of zinc, is not in the valence. It's not in the valence, valence. So the valence of gallium is just the 4s2 and the 4p1. So I could rewrite it as 4s2, 4p1 without even having the 3D in there. This is the valence of gallium. All right, now I showed you guys at the beginning of the year another way to do this. So if you look at gallium, you can see it's in group 3A. And for, if we look at the valence for boron, which is at the top of the group, I'm going to just move it up here. All right, it's going to be 2s2, 2p1. That's the valence of boron. Now, to figure out gallium, all you need to do is pay attention to what period it's in, all right? And you can see that gallium is in period 4. Then it's just a simple matter of switching the numbers to the correct period. So if we do that, we can see right away that we're going to get the proper valence of gallium. It's very, very easy to do this. It's very, very easy to do this. If you don't want to have if you don't want to think, you don't want to use your brain power with this, then the next best method is to do what we did down here. So let's practice again. And for this one, we'll look at arsenic. It has 33 electrons. All right, argon preceded it. So what we'll do is we'll put our argon in here like that. All right, and then we're going to have the 4s2. All right, and we have a 3d10. Right now we're writing the electron configuration. We're writing the electron configuration. We're not doing the valence yet. And then we see that arsenic has 33 electrons. So how many do we have so far? 3d10, let's see. So we have 18 here, and 2 is 20. And then we have 30. So it's going to be 4p3, like that. All right, now, again, we're to the right of zinc. So 3d10 is not included in the valence, so just put a line through it. And I'll rewrite the valence. So it's going to be 4s2, 4p3. We can confirm it using the trick that I showed you before. Arsenic is in period 5a. So the valence for nitrogen is going to be 2s2, 2p3, for a grand total of 5, which equals the group number, right? And then all we have to do is switch the numbers for the proper period. And again, arsenic is in period 4. So it would be 4s2, 4p3, which is what we got down here. So this is the correct valence of arsenic. All right, we can do the same thing with bromine. Let's go ahead and do it. We have Br, and it got a total of 35 electrons in it. All right, and again, argon preceded this, so we'll put our Ar in here. And then we're going to have the 4s2 and the 3d10. So right here we've got 30 electrons. And so the last 5 that we have left will go into the p shell. So it'll be 4p5. Now again, this represents, I'm going to circle it, this is the entire electron configuration. All right, remember, the 3d is not in the valence. It is not in the valence. Say it with me. It is not in the valence. So I'm going to rewrite this as 4s2, 4p5, and this would be the correct valence setup for Br. This is Br's valence. And again, you can get it the same way using the trick I taught you. You could go to fluorine, write the outer valence, and then switch the number for the proper proper period number, and then you've achieved the same exact thing. All right, with that, I'm going to close this video.